Okay, but why?
Hello there, and welcome to the fifth and final episode of Biscuits in Biophysics. I am actually out of biscuits for today, but don't worry because I'm not out of biophysics yet. So without further ado, let's get to the point. No, literally, a point. Now, if I want to take a picture of a point, then I should recognize that no camera is perfect, which means the image that I get is not going to be the point exactly. It's going to be a sort of blurred and spread out version of the point. And so, if I take an image of something that has several points in it, then that is going to look like a collection of several spread out points. I'm sure you can imagine that for biophysicists like me, who look at the detail of every point on the image to build their molecular structure, we should factor in that spread in the image as well. And that, ladies and gentlemen, is the idea of convolution. And it's literally used in any place imaging is involved. Well, it's also used in places that don't involve images, but why don't I let you find out what they are? So technically, it feels like every point on the image has sort of been multiplied by that spread factor. Now, mathematically, we say that the spread has been convolved over the entire object. So now I'm sure you can appreciate why the formula for convolution involves multiplying two functions. So let's cut to the chase. Why does the formula for convolution look so similar to the formula for cross-correlation? Okay, let's pause right there for a moment. Now, a lot of people have been wondering, what is the point of me talking about cross-correlation and convolution, and why on earth is it so amazing that two things have similar formulae? Well, here's the thing. If they have such similar formulae, then they're doing essentially the same thing. As you can see in these images from Wikipedia, both cross-correlation and convolution just involve the whole act of sliding one function over another to calculate its overlap. Now, if that's the case, then why on earth do they have such dramatically different applications in the real world? Now, that is what intrigued me about these two, and hence, I plan to explain them in these videos. Hope that helps. Well, it's sort of like how the lion uses the muscles of its prey for dinner and the bones of its prey as a toothpick. What I'm trying to say is, it might be the same formula, but each of these ideas use two completely different aspects of that formula. Of course, multiplying two functions will give you another function. And if you're interested in the shape of the graph that you get when you plot that function, then convolution is what you're doing. But if you're only interested in calculating one value of that resultant function, then cross-correlation is what you're doing. So there you go, ladies and gentlemen. We finally managed to solve that mystery that I've been hyping for 2 episodes. I guess you can correlate now that it's not too convoluted, is it? And with that, we finally come to the end of Biscuits in Biophysics. I hope you had an amazing biophysics week, and I hope my episodes were able to teach you something about this field. But hey, guess what? There's no need to feel bad about it, because I post biophysics videos every month. So if you subscribe to my channel, you can watch those videos and continue your journey of learning with me. So go ahead and smash that subscribe button and let me know in the comments what you thought about this show. And of course, if you have any other questions that you would like me to answer. Until then, I'm Varun from OK But Why. Stay safe, stay curious, and as always, stay tuned for my next video.